In 1977, a machine left Earth with a simple purpose. It was never meant to travel forever. It was never meant to reach the space between stars. And yet today, Voyager 2 continues to move farther away than its creators ever imagined. When NASA launched Voyager 2, the plan was clear and carefully limited. The spacecraft would visit the outer planets, gather data, and transmit its discoveries back home. Its lifespan was expected to be measured in years. Its mission had an ending. But space had other plans. As Voyager 2 crossed the solar system, it turned distant worlds into places we could finally understand. At Jupiter, it recorded immense storms and revealed a dynamic atmosphere filled with motion and energy. At Saturn, it exposed the delicate complexity of the rings, structures far more intricate than scientists had predicted. When it reached Uranus, it showed a world unlike any other, rotating on its side as if something long ago had knocked it off balance. And at Neptune, it captured violent winds and dark storms, giving humanity its first close encounter with the most distant planet. Each discovery reshaped science. Each image expanded our understanding of what a planet could be. By the time it completed this journey, Voyager 2 had already secured its place in history. It had done everything it was designed to do. But it did not stop. Instead, it continued outward, leaving behind the planets, moving toward a boundary that had only existed in theory. This boundary, known as the heliopause, marks the outer edge of the heliosphere, a vast bubble created by the Sun's solar wind. For decades, scientists believed this boundary would be gradual. A slow fading of the Sun's influence into the wider galaxy. A place where one environment gently blended into another. Voyager 2 revealed something very different. As it approached this distant edge, its instruments began detecting subtle but consistent changes. The familiar environment shaped by the Sun was beginning to shift. Then, in a relatively short span of time, everything changed. Radiation levels increased sharply. Plasma density rose. The magnetic field altered direction. These were not small variations. They were clear signals of transition. Voyager 2 had reached the edge and crossed it. In that moment, it moved from a region dominated by our Sun into interstellar space, a place shaped not by a single star, but by the combined forces of the galaxy itself. This discovery forced scientists to rethink a fundamental assumption. The solar system is not simply fading into space. It is enclosed within a structured boundary, a kind of cosmic shield. Inside this shield, the Sun governs the movement of particles and helps protect the inner planets from a large portion of high-energy cosmic radiation. Outside it, conditions change dramatically. Radiation becomes stronger. Magnetic interactions become more complex. The environment becomes less predictable. The idea that our solar system exists inside a protective structure carries profound implications. For billions of years, this boundary may have played a quiet but crucial role in shaping conditions on Earth. Without it, the radiation environment near our planet could be far harsher, potentially influencing the atmosphere, biological evolution, and even the stability of modern technology. And yet, this shield is not permanent. It breathes. Voyager 2 revealed that the heliosphere expands and contracts over time, responding to the Sun's activity cycle, which lasts roughly 11 years. During periods of high solar activity, stronger solar winds push the boundary outward, strengthening this protective bubble. During quieter periods, the boundary shrinks, allowing more cosmic radiation to move inward. Voyager 2 crossed this boundary during one of those quieter phases, offering a rare glimpse of how thin and dynamic this edge can become. It was no longer just exploring space. It was redefining it. Beyond that boundary, Voyager 2 entered a region once imagined as empty. A silent, motionless void between the stars. What it found instead was something far more complex. Interstellar space is not still. It is active, shifting, and structured. The spacecraft detected plasma moving in changing patterns, radiation rising and falling, and magnetic fields stretching across enormous distances. Rather than emptiness, it revealed something closer to a vast, invisible ocean, filled with currents, disturbances, and interactions. This is a kind of cosmic weather system, influenced by distant stars, ancient supernova explosions, and galactic magnetic forces that operate on scales almost impossible to imagine. One of the most unexpected discoveries involved magnetism. Scientists had predicted that the boundary between the Sun's magnetic field and that of the galaxy would be chaotic and unstable. Instead, Voyager 2 observed a smoother alignment than expected. This raised deeper questions. It suggested that the region surrounding our solar system might already be structured in ways we do not fully understand. Or perhaps the Sun itself, over millions of years, has influenced the interstellar medium around it. Either possibility points to a universe that is far more interconnected than once believed. Then came a moment that added new mystery to the mission. In 2019, Voyager 2 suddenly stopped communicating with Earth. For hours, there was silence. No data, no signal. After decades of continuous operation, the spacecraft appeared to go quiet without warning. Then, just as suddenly, it came back. Communication resumed. Systems stabilized. The mission continued. Engineers explained the interruption as a result of aging systems, an expected risk for a spacecraft operating far beyond its intended lifespan. But the data leading up to the event told a more complicated story. There were unusual spikes in particle energy. Subtle disturbances in the surrounding environment. Some scientists believe Voyager 2 may have passed through a highly energized region of plasma. Others suggest it encountered the distant effects of a shock wave moving through interstellar space, perhaps originating from a long-ago stellar explosion. There are even more speculative ideas, localized structures or phenomena not yet fully understood. Whatever the cause, the event served as a reminder that interstellar space is still largely unknown territory. Attached to Voyager 2 is one of humanity's most symbolic creations, the Voyager Golden Record. It carries sounds, music, greetings, and images from Earth, a small archive of life from one planet. It was created as a message. A gesture of curiosity and hope. Now, that message has traveled beyond the influence of the Sun and into the galaxy itself. Voyager 2 is no longer just a spacecraft. It is a marker of existence. A sign that a technological civilization once reached outward and crossed the boundary of its own star system. Even now, it continues its journey. Its power is slowly fading. One by one, its instruments will shut down. Eventually, it will fall silent. But its motion will continue. For millions of years, it will drift through the galaxy, long after Earth has changed beyond recognition. What it has already accomplished is extraordinary. It turned theoretical boundaries into observed reality. It showed that the edge of our solar system is not abstract but structured and dynamic. It revealed that interstellar space is not empty, but filled with motion and interaction. And perhaps most importantly, it demonstrated something about us. From a small world orbiting an ordinary star, humanity built a machine capable of reaching beyond the Sun's influence. A machine that continues to explore, adapt, and send knowledge across unimaginable distances. Voyager 2 is still out there. Still moving. Still carrying a question that has defined humanity for as long as we have looked at the sky.